Hello and welcome to my training program. Today I'm going to give you a training on Matlab Simulink, the target audience of beginners. If you are already familiar with Matlab Simulink, then this training is not for you. This is made for the beginners. For those who want to do self-start, self-learning about the Simulink, then this video is for you. So I'm going to run a couple of classes starting from the introduction to model building and some best practices and things so on. MATLAB Simulink is used in various industries and domains. If you want to learn about how to use the MATLAB in automotive domain as an embedded tool, then follow this tutorial or the training program. Otherwise, you can skip this program. These are the prerequisites for this training program. So the first one is you need a laptop or a PC with good configuration. MATLAB won't run below Windows 10, so you need at least Windows 10 or 11 operating system with at least 8 GB RAM. Then you need a basic programming knowledge, preferably C or C++ or Java, or if you are familiar with other embedded tools, then also it is okay. Then you need to install the MATLAB on your computer. Either it could be a student version or trial version or license version. Anything is okay. The next prerequisite is embedded system concept. You should at least familiar with OS task handling and message handling and so on. Okay, the final one is if you have already working experience in automotive software development, then that would be a very grateful one. You can easily follow this training program. At the end of this training program, what you will learn out of this is listed over here. So you will learn about model-based development, like how to create an input signal, output signal, and how to create the model, state flows, how to create the tuning parameters, and how to handle the tasks. And also you will learn about the best practices used in automotive domain and nevertheless about the component testing. So the module testing, component testing, and you will also learn about the MCDC coverage. Before jumping into the tool, let's talk about one task. Suppose say you have assigned with the task that you have to develop a hill hold control using Matlab Simulink. Okay, then how do you develop? So this is the task which we are going to consider it, and we will talk about this task uh, throughout our training sessions. So let's get familiar with this task. And so the hill hold control will prevent the vehicle rolling back when you are park your vehicle on a slope. And when you want to drive away, then you have to move your leg from the brake pedal to accelerator. So meanwhile, there may be a chance that your vehicle may slide backwards. So this hill hold control functionality will help you to hold the car for about 2 seconds. So during this time, you can move your leg from the brake pedal to accelerator and apply the accelerator, and then you can easily move your vehicle without sliding backwards. So this is the functionality available in the brake control module. Before start doing the development in the Simulink, you should be familiar with the software architecture of this component. So you should familiar with what are the inputs for this payload control and what are the outputs. So for the first main input is vehicle speed. So using this vehicle speed, you can come to know whether the vehicle is in a stationary situation or in moving state. The next input is a slope. So the slope indicates whether you are in forward slope or downward slope. And the gear, it's the gear position, which tells about whether your vehicle is in park gear or forward, reverse, or neutral. The next signal is a brake applied. So this is a signal which tells you about whether the brake is applied or released. The next signal is acceleration position. Uh, from this signal, you can come to know whether the accelerator pedal is pressed or not. And then the next signal is the engine torque. So using this signal, you can determine whether the engine torque is sufficient to move away from the current slope. The final one is the disable signal for this component. So when the disable signal is set to true, then you have to disable this component. So this is the requirement. And what are the output signals generated out of this is listed over here. So first one is the status, whether the hill hold control is active or deactivated. And the next one is the pressure target. So how much is the pressure needed to hold or release. Okay, today we will close our training session with this context setting. So in the next session, we will learn how to use the tool to create inputs and outputs under the basic um, model. Okay, see you in the next class.